Okay, we are going into a very, very important part of maybe the most important part of business analytic, okay, in the upcoming hour, okay. So, see, what we are trying to do is to connect prediction into decision, okay. So, well, what we have already covered is the thing that already covered in the MIT online course, okay? But that is not good enough, okay? Actually, this is a very good case, okay? The predictive medication is a very good case, but I think the MIT just do not take the full advantage of this example, right? Okay, it just tell you how to do the prediction and how to measure how good the prediction is, right? But that is not our purpose for business analytic, okay? For business analyst, what we want to do is use this prediction to make decision. That's what we want to do, okay? These things, the DPP, right? The histogram is what the model give us, right? Okay. At the end of the last hour, I told you that the entire information that the model can give us is actually in this distribution, right? It gives us the distribution of predictive power, of predictive probability on y equal to 0 and y equal to 1, right? Okay, so this histogram, this DPP histogram, is actually the output of the model, right? So, but the output of the model is not a decision yet, right? In this case, we want to have a cutoff, right? So, and above the cutoff, we want to take action. Below the cutoff, we don't want to take action, right? So, in a business situation, it's not our purpose to predict 0 and 1, right? Okay, our objective is to determine which patient should I take action, right? For example, if I have a drug, as I already mentioned, right? So where is the cutoff probability that I should give the drug or do not give the drug, right? We need to determine the threshold, isn't it? Right? Otherwise, the model would not help you in any way, okay? If you do the prediction and do nothing, then the prediction will not help you, right? At all, isn't it? You want to use the prediction to take action, but in order to take action, you need to determine the cutoff point, right? How? How can you determine the cutoff point? That's what I'm going to cover in this hour, right? And that is actually the most important thing in business analytics. One of the most important things, right? Because it connects this prediction into decision. Now, we do not know which cutoff is good, okay? So how to determine it? Now, before doing that, we need to think about one thing, right? For business decision, we are always looking for the optimum expected payoff, right? When we are doing business decision in an uncertain situation, because it's uncertain, right? So we try to find the optimum solution that lead to the best expected payoff, right? Expected payoff means that it would not always happen, but you can expect that it will have the best result, right? Because you have the uncertainty in front of you, right? So the point is we want to know the expected payoff, right? whatever cutoff it is, it will generate a confusion metric. Okay, but the confusion metric itself is not payoff, right? It just tells you that the count of the 4 cases, right? In this confusion metric, it's just the count of the 4 situation, isn't it? It's not the payoff, right? Okay, so actually you need to, in order to calculate this expected payoff, you need to have a payoff matrix, okay? Along with this confusion metric, there would always be a payoff matrix, okay? Let me do a real example. It would be easier to understand, okay? So in this medical medication case, now if you if the patient is like, if it was actually poor care equal to 0, it means that it's good care already, okay? And you do nothing, right? Negative, right now, negative means I do not do anything, right? So it's good care and you doing nothing, then, well, nothing will happen, right? So the payoff will be 0, right? Because he is already good care and you're doing nothing on him, okay? And that, the payoff is 0, right? So, but if this patient is poor care, right? This is the actual value, right? So if the patient is poor care and if you do nothing, right, there will be a large cost, right? Large risk of cost, I should say that, right? Okay. And how do you get this number? Because you are running this insurance company for a long time, right? Right? So you should have according to your historical data, you should know that if for those poor care patient, if you do nothing, the average cost to you, right? I mean, from your business history, you should know the average cost, right? If you do nothing to this poor care person, right, it would have some very serious complication, right? And in average, right, of course this is assumption, right? Okay, it's the estimation according to your business historical data, right? Assuming that you will have minus 100, okay, and that minus 100 could be like minus 100,000 US dollar, right? Things like that, okay. It means that if this guy is like poor care and you do nothing, then in the future it would cost you like 100,000 US dollar in average, okay? And you know that, right? Because you are an insurance company, okay? Now you have a drug, okay? You have a drug and the cost of the drug is like 10,000, okay? Well, that drug is very expensive, okay? It's like 10,000, okay? Maybe it's not a drug. Maybe it's a kind of a treatment, or maybe it's some. You know that in the U.S. the cost of medication is like very, very high. Like it's like 100 times higher than in Taiwan, right? I'm not exaggerated. It's like very, very high, right? So if you have a treatment that costs 10,000, okay, then so if this person he is good care, right, and you apply that 10,000 on him, okay, that 10,000 is kind of waste, right? Right? So it would cost you like 10,000. If you give the treatment to the patient who is actually good care, right? Okay. Why should you do that? Actually, you don't know, right? You don't know this guy is good care or bad care, right? The model do the prediction for you, right? And the model could predict wrong, right? Isn't it? Okay. So in this cell is actually like the model is predicting wrong, and you are giving this treatment to someone who is actually good care. Okay, so that would cost you the cost of the treatment, right? In this scenario. And then what is this one? This one is like if I'm applying the treatment to this guy who is poor care, right? I can reduce it, the risk, right, from -100 to -50. Okay. If the drug, when you apply to the poor care person, right, because you are doing drug experiment, right? Okay. So if that treatment, when applied to the poor care people, can reduce her risk can reduce the average risk from -100 to -50. Okay, but you say that this is -60, right? Because you also need to add on the cost of the treatment, right? You get my point? Okay. So this cell is actually the reduced risk plus the cost of treatment, right? Okay. You get my point? Okay, so in this scenario, that now according to your experience, right, you should get this information from your accounting person, right? Your accounting person can give you this information, right? Okay, so along with the confusion metric, you actually have this payoff metric, right? Okay, so to get the expected payoff is actually quite easy, right? You simply multiply the two metrics, right? I multiply this on this, this on this, this on this, and this on this, right? It's actually a matrix multiplication, right? And in R, it's very easy, right? Because metric is just the other type of array, right? So you simply like two metric, you just multiply them, and then you sum them up, right? So this is the sum of product, right? Okay. So this expected payoff is just the sum of product of confusion and payoff metrics. You get me? Right. Okay. So in this part, when we have the payoff metric from our like business scenario, and when we have a confusion metric, we can calculate the corresponding expected payoff, right? Okay. So the only thing that is left open is actually this cutoff, right? Because the confusion metric will change with this cutoff, right? And we still do not know that which cutoff is best, right? Okay. But that is easy because we are using R, right? We can use R program, right? So I can use our program to scan the entire cutoff, right? So cutoff is from 0 to 1, right? So I write a simulation program, right? So I can scan the entire range from 0 to 1, right? When I do the scan, I can in every step I will have a confusion metric. So in every step I will know its expected payoff, right? So at the end, I will see something like this. At the end, I will see something like this, right? I mean, if I use an R program, if I change the threshold, this is the threshold, the cutoff, right? If I change the cutoff from 0 to 1, okay, scan the entire range, okay, I will see that for every step, I will have a confusion metric, right? And with that payoff metric, I can calculate the expected payoff, right? So here is the expected payoff. So I can see that, I can see an optimum cutoff, right? For example, in this case, the optimum cutoff occurred in 0.16, which means that whoever is whoever the expected probability is higher than 16%, I will apply the treatment. Okay, that would give me the maximum expected payoff, isn't it? Right? And this is the way that we can use the model to determine the threshold of action. Did you get my point? Okay? Let's go back to this chart again, right? So this is our objective, right? Prediction is not. Prediction only give us this DPP, right? And we want to make a decision that where is the optimum cutoff in this DPP, right? And in order to do that, we need to have a payoff metric, right? Okay, and then together with the payoff metric, we can determine the optimum cutoff, which give us the maximum expected payoff. Okay, that is the logic. Okay, and let's go through the logic in our notebook. Okay. Now it's in 11D or 11D, and actually this chunk is we already did it, right? So I built a model already, and then what? Sorry, I should set it as working directory. And then what is this thing doing? I'm doing I think this code is just to draw the DPP by ggplot, right? Just to draw the DPP. Actually, you don't need to draw the DPP. Okay, if you do it enough of times, right? Drawing DPP is not necessary, right? It's just for you just draw the DPP like for fun, right? Okay. Actually, you don't need to do that, right? Okay. So, but the thing that we must do is actually we need to estimate the expected payoff. If you want to estimate the expected payoff, you will need a payoff matrix, right? Okay. So as I say here, in order to estimate the expected payoff, we need to like do the sum of product for payoff and confusion metric, right? So the confusion metric will be created by applying the cutoff to the DPP, right? Okay, and the problem is this matrix, right? Okay, in this metric you actually need to do some assumption, right? It's not just a sheer assumption. It actually comes from your historical data, right? You can know you can build a metric like this, right? If this true false is actually the poor care, right? This is poor care and this is good care, and this is no action and this is action, right? You need to like do this assumption, okay? So and turn that assumption into a metric. Okay. There is one thing that you need to be careful, right? This is the way to define a metric in R, right? Okay. It actually go by row. Okay. So this 0. So this 4 thing, right? The order is here. It's this way. Okay. Order is this way. You need to remember, otherwise it would like get messed up, right? Okay, because your confusion metric is like 0, 1 and no egg, right? So the payoff metric has to be exactly the same. You need to make sure that it was exactly in the same position, right? Okay. So now you have this payoff matrix, right? What you need to do is to like write a simulation program, right, to simulate that when I change the cutoff from 0 to 1, right, then I can calculate the confusion metric, and I just do the like, I just make the program do this, right? So for every cutoff, I will have a confusion metric, right? So for every confusion metric, I can have an expected payoff, right? So in this way, for every cutoff, I will have a, right? I will have a expected payoff, isn't it? Okay. So actually, the way to make the results is quite simple. It's just like a few lines of code. Okay. First of all, you need to, every time when we want to do the simulation, you should first of all you need to generate the vector of cutoff, right? Because we want to change the cutoff from 0 to 1, and every step is 0.1, 0.01, sorry. Okay? I want to do it like from 0 to 1, and every step, right? Every step is 0.01. And that is the function of sequence, right? So you define a cutoff as a sequence of numeric vector, right? And then you do a s apply. You apply this function to the cutoff, and the function would actually calculate the sum of product of these two metrics, right? Okay. The payoff matrix you already defined here, right? Payoff matrix is already defined. So for every cutoff, you need to determine its confusion metric and do the sum of product. Okay. So and this is the sum of product, right? And this is the way to generate the confusion metric. Looks a little complicated, and the way that it is so complicated is to make sure that we want to make sure that it's actually just a simple table, right? We are generating the confusion metric by using a table, right? The reason that inside the table they are like, here is actually it's still y, right? And here is actually the p for now is the cutoff, right? Okay, so the reason that I need to put a factor on this is I want to make sure that the order of the confusion metric is exactly the same as the payoff metric. Okay? The reason that I want to put a factor here is because I want to make sure that the order are like aligned to each other, right? So I don't confuse, right? Okay. So if you do it like enough of time, maybe you can like just do a simple table here, right? If you are sure that you will not mess up the thing, right? So actually, this s apply, it apply a function to each of this cutoff, right? And the function would actually calculate the corresponding expected payoff, right? So at the end, this s apply will return a result. It will return a result vector, right? Okay. So for every cutoff, you will have a result vector, which is the expected payoff, right? And the rest of the code, here, is just to produce this chart. Okay. So the simulation is like 4 lines of code. Okay. and the rest of the thing is just to make the plot. Okay, I do not have time to cover the plotting code. Okay, well, but basically it was just plot use the cutoff as the x-axis and use the results as the y-axis and make a line plot. Okay, you actually can do this here. Okay, so let me go to this point, and if I run the cutoff and I run the result, so I will have a cutoff vector, and I will also have a result vector, right? So I can actually simply plot. Sorry. You actually you will actually draw the plot already, right? So if you want to make it prettier, it's just time. It will be a line plot. Okay, so the reason that I need to do so many lines of code is just to make it like prettier, right? Make it look better, right? Okay, so if you want to do a simulation, it's with just like a few lines of code. You want to plot the result. If you don't care about the beautifulness, if you don't care about the beauty, then the code is also very easy, isn't it? Right? Okay. So now you know that for every cutoff, which cutoff will give you the best expected payoff, right? And this is the way that you can connect your prediction to your decision. Okay? It basically tells you that sorry. The best cutoff is at 16%, right? So if you apply the treatment to whoever the predicted value is larger than 16%, right? Then your expected payoff is like here. It's like minus 2360. The best payoff is still negative because you are trying to do a cost reduction, right? Risk cost reduction. You are doing the risk cost reduction because you are an insurance company, right? So it's still negative, but it's better than here is actually cutoff equal to 0, right? What does it mean by cutoff equal to 0? It means I would apply the treatment to everyone, right? Okay? And here is like I do nothing, right? Cutoff equal to 1. So I'm doing the treatment to nobody, right? So if I'm doing nothing, actually my cost would be like, well, the unit is hard to tell. Maybe it's like 3.2 million, something like that. Okay? If I doing nothing, this poor care guys would cost me like 3.2 million. Okay? Then if I apply the treatment to everyone, okay, well, it's better, but it's still like more than 2.6 million. But if I do it if I selectively doing this treatment, right? What I mean by selectively is because the model will select the target for us, right? Because when we apply the model to all of the patients, the model will tell us a predicted probability of each of these patients, right? So I know that whoever the predicted value is larger than 16%, I should apply the treatment, and in this way I would get the best expected payoff, right? which will reduce my risk from like more than 3.2 million to less than 2.4 million. It's a large reduce, isn't it? Right? Right? So that it's why we want to build model, right? The reason that we build model is not for prediction. It is actually for doing decision, right? And in this way, it will help you to select the target, right, that you want to apply the treatment, right? Okay? In this way, it will help you select the patient and actually evaluate the cost effectiveness of your treatment. Isn't it? Right? This is the right way to use model, right? If you stop here, then the model will not help you at all. Right? You need to do one step forward, and that one step forward is very, very important. And that's the beauty of R, right? Because after you build the model, you do the prediction, you can actually do a simulation in a few lines of code. And with this simple simulation, you can do a lot of things. Okay? We're running out of time. Let me do this very quickly. Okay? So actually, in our notebook, there is a simulator. Right, there's a simulator, and in order to use this simulator, you need to do one thing. Here, there's a bottom here, right? On the right of the knit, there's a gear, right? You need to pull down the gear, and you need to select the chunk output in console, right? You need to do that. Okay. Drop this drop down menu and choose chunk output in console, right? So in order to run this chunk, you need to do that. And after you do that, and you run this chunk, you'll see this chart here with a gear here, where you can actually adjust your payoff matrix, right? Okay? As I told you, the payoff metric is assumption, right? And sometimes you are not 100% sure about the assumption, right? So you need to like kind of adjust these things. For example, I told you that this is the cost of the treatment, right? So what happens if the cost of the treatment increase? See, if the cost of the treatment increase from 10 to 15, right? Then my optimal cover would jump to like 36, which means that less people, in order to get the best result, I should treat less people, right? Because the treatment is costly, isn't it, right? And if the cost like drop to 5, yeah, you can see that I almost use the treatment to almost everyone, right? So this simulation package actually can help you do this, right? So you can adjust the payoff matrix, right? To every different business situation, right? And that's our. Sorry, it's already 45. Let me like give me like 5 minutes to cover the. Actually, it's your assignment, personal assignment this week. Okay, so I want you to use this simulator, okay, to do the quiz. You don't need to write program, right? Simulator is already there. And I want you to use this simulator to like I want you to like answer this, do this practice, right? Okay, do this practice. So I might have to do some explanation, right? The first exercise is that if you see this, right, you will see that doing for everyone is better than doing nothing, right? But this is not always the case. Okay, if you adjust the things, right, you might see that sometimes you will see that doing nothing is better than doing for everything. Okay, I want you to like do some practice, right? Change the payoff matrix, right? And try to figure out, right? Try to figure out that in some situation that doing nothing is better. In some situation, like doing for everyone is better. But the selective action is always better than the two extreme resolution. Let me say it again. In some business situation, doing nothing is better. In some business situation, doing for everyone is better. It really depends on your payoff metrics, right? Okay, which connect to your business context, right? Okay, but in either case, you will find that selectively doing to part of the patient is always better than doing nothing and doing for all. Okay, that is the first practice that I want you to do. Okay, and the second practice is like this. I want you to select among several solutions. Now, instead of you only have one treatment, now you have five different kind of treatments. Okay, the cost of the treatment is 5, 10, 15, 20, and 35. And it can reduce the risk from 100 to 70, 60, 50, 40, and 30. So the more expensive the treatment is, the more reduction it would incur, right, to the risk cost, right? So you're not only selecting among customer, the same thing can help you select among different solutions, right? If you have like 5 different type of treatment, right, and you know the cost and their effect, you can use the same tool, right, to help you select the treatment, right? Okay, you do not need to write code. You simply use this thing, just adjust the payoff metric. You should be able to answer all of the question in this quiz. Okay, and that is your second personal assignment for this week. Okay, you get me, right? Okay, so these assignments are very important. Let me emphasize it again, because they help you to connect analytic to decision, connect the result of analytic to strategic decision, right? It helps you to choose among the treatment, choose among the target, and estimate the cost effectiveness. Okay? And if you do not do the simulation, all of your effort in doing the model is wasted. Okay? Okay, that's all. So we have 10 minutes to do the where is it?
Just open the other PowerPoint.
What?
I have already opened it.
Okay, PowerPoint. Okay, this is the teaching evaluation. So I think you finish this, then you can leave. Okay, okay. Okay. Should I leave?
Yes.
Okay. But this is my notebook though.
Oh.
Okay. So I wait outside.
Okay, you gotta take only a few minutes. Hi everyone, we need to do our teaching evaluation for this course for final time. So please scan the QR code, or if you have laptop, you can search 中山教学意见调查 or evaluation NSYSU. And then after you log in, you can choose your language preference here. And then we will need to do 2 evaluations. One is teaching evaluation, the other is learning outcome. So it will be, after you've done this one, the second one will be followed. And you might need to choose language preference again for the second time. So after you log in, choose the language and choose the course. You might have the course list here. You must done many times recently. So after you successfully submitted, there should be a time and date that shows at the end.
Let me turn off the video recording.
Oh, okay,
Still
okay.
off, so let me turn it off. Let me turn off the video recording.